Hello everyone. In this problem, there are three objects, A, B, and C, are moving along the x-axis. And there are three collisions. The first collision occurs between B and C. And second collision is made between A and B. And the A and B move together, and then they collide with C. And at any point, the sum of the momentum among A, B, and C is 0. So from the graph, we can set the velocity as the length divided by the unit time. In this case, unit time is t0 and unit length is capital L. So V is L divided by t0. Before the collision, the velocity of A is 10 times L divided by 5 times t0. So that's 2 times L, 2V. So the momentum of A before the collision is mass of 8 times 2V. And the momentum of B before the collision is mass of B times the speed of B is 2/3 of V. And there will be the momentum of C before collision. That's mass of C times, because we don't know the speed of C before the collision. Let's say that's Vc. And because the sum of the momentum is 0, this should be 0. So that means, because the momentum of A and B is positive before the collision, to make the sum 0, the momentum of C should be negative. That means C was moving left before collision. So the first statement is right. C's direction it was negative x when t is t0. And after the first collision, momentum is conserved. So the momentum before the collision between B and C is this. And after the collision, the velocity of B changes to the negative direction. So B now is moving to the left. And the magnitude of the velocity is 4L divided by 2T0. That's 2 times V, and the direction is negative. And the velocity of C after the collision, we can find the velocity from this graph. Before the first collision and the third collision, C was also moving. So if we connect these 2 points, that makes the C's velocity. And that is 2L divided by 4 times T0. So C's velocity after collision is minus half of V. And after the collision between A and B, the momentum is also conserved. So the sum of the momentum before the collision between A and B is ma times 2v, and mb times minus 2v. And after collision, they move together, and the velocity is 2L divided by 2 times T0. That's V. So from this equation, if we cancel V, mass of A is 3 times mass of B. So that means before the collision between A and B, when time is 40, because mass of A is 3 times mass of B, and their speed is the same. That means the momentum of A is 3 times a momentum of B. So the second statement is not correct. So we can change a mass of A to 3 times mass of B in the first equation. So that makes 6 times mb times V plus mb times 2/3 of V plus MC times VC equal to 0. And from the second equation, we can move this to the left side. That makes 2 times NB times V plus NB times 2/3 of V plus MC times VC. That's equal to MC times minus V over 2. So if we subtract these two equations, 4 times NB times V is equal to MC times V over 2. So after cancel this V, MC is equal to A times NB. So mass of C is A times B. So third statement is correct. So the right answer is the fourth choice. That's it for this video, and thanks for watching.